Okay, class, in this lesson, we are going to learn to add and subtract, or in this case, find the sum and difference of rational expressions. So let's go ahead and get started. Before we do, I wanted to cover one simple concept and just kind of review this because this is really the basis or foundation for this particular lesson, okay? So let's say, for example, we have the following fractions. 1/3 plus 1/4. Okay? Now, if you recall, the way that we add these fractions is to find the least common multiple. So in other words, we need to find something that the 3 in the denominator and the 4 in the denominator can be brought together. And the least common multiple here would be the number 12. Okay? So to get this to 12, we need to multiply this fraction by 4/4. And we also need to multiply this fraction by 3/3. So when we do, what we end up with is 4/12 plus 3/12. Okay? Now the reason we do that is because when the denominators are not the same, you cannot combine those fractions. You can only combine them once the denominators are the same. That is the rule for adding or subtracting fractions. So in this case, we have 12 as our denominator, and since they're the same, we can now bring them together, and we get 7/12. Okay? So this process of combining fractions is exactly what we're going to do when we're adding and subtracting rational expressions. So let's go ahead and get started with example number 1. Okay, in this particular example, we see that we have two rational expressions, x over x plus 4 plus 5 divided by x plus 4. And in this case, both of these denominators are exactly the same, and so there's nothing we need to do in terms of finding the least common multiple because the denominators are the same. So when you add these together, you just add the numerator and then write down the common denominator, and this becomes your answer. Okay, let's take a look at another example. So here we have another set of rational expressions, and the denominators don't immediately look like they are identical. However, if you take this polynomial and multiply them together, what you'll see is the following. So we're going to rewrite the first rational expression as is, nothing has changed here, plus we're going to go ahead and write the numerator of the second rational expression, and then now we're going to multiply out the denominator, and this becomes x squared plus 3x. Okay, so now you'll see that the denominator for both rational expressions are the same, and when we have the same denominator, we can go ahead and add the numerator, and so this becomes 2x plus 1 plus 3x minus 8, and that is all over x squared plus 3x. Okay, then the next step is to combine like terms. We need to simplify this numerator, and so we have a 2x and a 3x, so those can come together, and we have a positive 1 and a negative 8, those can come together as well. So that becomes 5x minus 7 over x squared plus 3x. Okay, and this becomes our answer. Okay, in the next couple of examples, we're going to go through the process of finding the least common multiple. Okay, so if you recall from the fraction exercise that we did at the very beginning of this lesson, it's finding common ground among the denominators. Okay, so we're going to assume that these are in the denominator, and we have two polynomials, okay, or two expressions here. And so what we're going to do is break this down into its lowest parts, and so this becomes x plus 2 times x plus 2, and this polynomial factors out to x plus 2 times x plus 3, okay? Now, in comparing these two sets, we see that we have two sets of x plus 2, but here we only have one. However, this has an x plus 3, and this does not. So what this means is, in order for both of these to be the same, we need to have an x plus 3 for this first set, and for the second set, we need to have another x plus 2, okay? And so when we do that, we find that our least common multiple is x plus 2 times x plus 2 times x plus 3. Okay, let's go on to another example. So that was two different sets. Here we've got three different sets. We have an x cubed minus 9x, an x squared minus 2x minus 15, and then the third one is x squared minus 5x. Okay, so the first thing we're going to do is separate them and break it down to its lowest parts. This becomes x times x squared minus 9 when you factor out an x as the greatest common factor. And then what we'll find is that this can be factored even further, and this comes out to x times x plus 3 times x minus 3. And then the second set, this factors out to x minus 5 times x plus 2. And then the last set, this breaks down to x times x minus 5. Okay, now in looking at all three sets here, okay, what we're finding is that to achieve the least common multiple, we have to take a look at what this is missing across both of these sets. Okay, we have an x here, we have an x here, so that's fine. We've got an x plus 3 here. There's no x plus 3 here, so we'll take care of that later on. We've got an x minus 3. There's no x minus 3 across here, but what we do need is an x minus 5, because there's an x minus 5 here and an x minus 5 here. So we need to multiply this by x minus 5. And this has an x plus 2, so we're going to need that in this set as well. Okay, so we need an x plus 2. Okay, and then looking at the second set, we have an x minus 5 here, we got an x minus 5 here, this has an x minus 5, so we're good there. We've got an x plus 2 here, we've got an x plus 2 here, so we're good. However, this does not have, or this set does not have an x plus 3, an x minus 3, or an x, okay? So we need to add, let's see here, we need an x plus 3. We also need an x minus 3, and we need an x. Okay, and let's go ahead and move this over a little bit. So with this set, we have an x and an x minus 5. This has an x, x minus 5, x, and x minus 5. So we're good there. What we do need is an x plus 2. In this set, we need an x plus 3 and an x minus 3. Okay, so let's go ahead and add those. We need, let's take a look here. We need an x minus, or I'm sorry, an x plus 2. Let's keep the colors consistent here. X plus 2 here. We also need an x plus 3. And we need an x minus 3. Okay, so now you'll see that all three sets have the same values, right? The same components. And so we would say that our least common multiple is x times x plus 3 times x minus 3 times x minus 5 times x plus 2. Okay, that was a little long, but hopefully that made sense. So let's go ahead and put all of this together and solve the next example. All right, here we're going to add both rational expressions where the denominators are not the same, okay? So to do this, what we want to do is break it down, break the denominator down by factoring. So the first expression is going to be x plus 3 divided by, And this x squared minus 1 factors out to x plus 1 times x minus 1. I think I'm going to move this down below so we've got a little more room to work with. All right? And I'm going to leave a little space in between what we just put together and the plus sign, and go ahead and rewrite or write the next rational expression and factor out this denominator. We see that this factors out to x minus 2 times x minus 1. Okay? So the next thing we do is take a look at the denominator and find the least common multiple. This has an x minus 1, this has an x minus 1, this has an x minus 2, this does not, so we need to multiply this expression by x minus 2 over x minus 2. And then in looking at this denominator, we see that this has an x minus 1, this already has an x minus 2, but it doesn't have an x plus 1, so we need to multiply that expression by x plus 1 over x plus 1. Okay, so now let's go ahead and put those together. This is going to equal x plus 3 times x minus 2 plus 2 times x plus 1. That's our numerator. And then our denominator is our least common multiple, which is x plus 1 times x minus 1 times x minus 2. Okay, next step is to multiply these together and these together as well. And when we do, we should get x squared plus x minus 6 plus 2x plus 1. Okay, so that is the second set, and this is the first set. And that's all over our least common multiple, which is x plus 1 times x minus 1 times x minus 2. Okay, next step is to combine like terms. Okay, we see that we have an x squared here, and there are no other x squares here, so we're going to go ahead and write x squared in the numerator. The next component is a plus x and a plus 2x, so that's going to be 3x. And lastly, we have a negative 6 and a plus 1, so that gives us a negative 5. And that's going to be all over our least common multiple, which is x plus 1 times x minus 1 times x minus 2. Okay. Now, next step is to factor this polynomial. When we do, we get x, did I do that correctly? My apologies here. I want to make sure I did this right. 3x minus 5. Okay, so it looks like x squared plus 3x minus 5 does not factor evenly because there are no factors of negative 5 such that when you add them together, we get a positive 3x. Okay, so let's make sure I multiplied this correctly. X squared minus 2x minus 6, that works. Oh, there's my mistake right here. 2 times x is 2x, 2 times 1 is 2, okay, not 1. So that needs to change to 2, which means this addition, negative 6 plus 2, should be negative 4, okay? So let's go ahead and fix that. That should be minus 4. All right, now this polynomial should be factorable, okay? So this becomes x plus 4 times x minus 1. And that is all over x plus 1 times x minus 1 times x minus 2. Okay, so we see that we have an x minus 1 up here in the numerator and x minus 1 in the denominator. So what that means is we can go ahead and cancel those out. And we're left with x plus 4 over x plus 1 times x minus 2. Okay, this is our final answer. Now remember, with rational expressions, we need to be careful and specify our domain. And so here we need to say where x does not equal -1 or 2. Okay, this -1 comes from this expression here, because if x is -1, this becomes 0, and that makes the denominator 0, and we can't have that. And this 2, if you plug that in here, makes this expression 0, and when you have the 0 here, this denominator becomes 0. Okay, and so that cannot happen as well. So this becomes our final answer with the domain specified. Okay, so I'm kind of glad that I made this error early on because and the reason I'm glad I did that is because when you go through a series of steps like what we just did, and there are multiple components to it, it's really important that you are very careful with your calculations, okay? Because if you're not, like you saw over here, one minor error will throw this entire problem off. So it's really important to go through each step very, very carefully, and you may even want to double check your calculations as you go through it to make sure that you're not making any errors along the way. Okay, last example here is exactly the same as what we did, except this time we're going to subtract. And when we do subtract, we need to be really careful of the subtraction sign, okay? And I'll explain why in a minute. So let's go ahead and break this down and factor out these denominators, okay, so that we can see what's going on here. So this is going to come out to x plus 1 over, and the denominator factors out to x minus 8 times x plus 2. Okay, and then I'm going to leave a little space. We're going to subtract x plus 1 all over, and the denominator here factors out to x plus 4 times x plus 2. Okay, so now we need to find the least common multiple, and we see that this denominator has an x plus 2, which this does. This has an x plus 4, which this does not. So we need to multiply this fraction by x plus 4 over x plus 4. Okay. This has an x minus 8. This fraction does not have an x minus 8. It has an x plus 4 and an x plus 2 on this side, so we're good there. We just need to include x minus 8. So we need to multiply this by x minus 8 over x minus 8. Okay, so then we go ahead and put that together, and we get x plus 1 times x plus 4, okay, minus x plus 1 times x minus 8. And that is all over our least common multiple, which is x minus 8 times x plus 2 times x plus 4. Okay, so now what we need to do is multiply these out, these binomials together, and when we do, we get x squared plus 5x plus 4, okay, that's one set, minus, okay, this is where you need to be careful. When you subtract, we are subtracting this entire set, okay, and when we multiply the binomials out, the x plus 1 and the x minus 8, we'll get x squared minus 7x minus 8. And that is all over x minus 8 times x plus 2 times x plus 4. Okay, so now what we're going to do is distribute this negative across this entire polynomial, and all you're doing is you're dropping the parentheses and you're going to negate all of these monomials, okay? So this becomes x squared plus 5x plus 4. Here we can drop the parentheses because they're all being added together. So with or without the parentheses makes no difference to the operation. This is where most people make mistakes. So we're going to subtract x squared, but then we're going to add 7x because we have to negate negative 7x. And then we need to also add 8 because we need to negate negative 8. And that is all over x minus 8 times x plus 2 times x plus 4. okay? So now we need to simplify the numerator, and we look at the x squared first. We have an x squared and a negative x squared, so those cancel out, okay? We have a 5x and a 7x, so we're going to combine those like terms. And we have a 4 and an 8, so we're going to combine those as well. So that comes out to, let me change this color here. That comes out to 12x plus 12 all over x minus 8 times x plus 2 times x plus 4. Okay, and then we need to factor out a 12 to see if we can cancel anything else. And when we do factor in the numerator, that comes out to 12 times x plus 1 all over x minus 8 times x plus 2 times x plus 4. Okay, and if we take a look, we have an x plus 1 up here. There is no x plus 1 down here, okay? So this is in its simplified form. The only thing we need to do here is to specify the domain. So we would say where x does not equal 8, negative 2, or negative 4. Okay, so that is our answer for this subtraction of rational expressions. Okay, a lot of steps here. Hopefully this made sense. I would highly recommend that you go back to the beginning of the recording and listen to this again so that you have a better understanding of the mechanics and why we do certain things. All right, thank you so much.